Okay, so everything we're going to do multiplication. It's not terribly hard. It's just one of those things you just got to keep up with what you're doing because the multiplication is going to be that you're just multiplying numbers together. So that part's not going to be too bad. But basically, here's what it is. It says the first thing we've got before you can actually do multiplication is you've got to check the matrix that you're multiplying together and see if their sizes match up. Okay, now, and when we were adding and subtracting yesterday, everything had to be the same size. For these, when you're doing multiplication, they don't necessarily have to be the same size, but the key thing you've got to have is if the columns and the rows match up for this thing. Okay, so if the columns in the first one is the same size as the rows in the second one, then you can multiply them together. So basically, here's what we've got. So if matrix A is 2 by 4, matrix B is a 4 by 3. It says, can you do A times B? Here's all you have to do to figure out if they work or not. All right, here's all you have to do. If you're going to do A times B, you write down what size matrix A is. You write down what size matrix B is. And if you figure out what the sizes are, if these two numbers are the same in the middle, then yes, you can. Okay. If it asks you then what size it's going to be, the two things, so once you scratch those out, that those are the same, whatever's left over, that's going to tell you what the size of the matrix is going to be when you get finished. So numbers in the middle have to be the same. If they are, then whatever two numbers left over in the front and the back, that's the size of the next matrix that you're going to get when you multiply together. Okay, now if you flip it around, if we do B times A, you put matrix B first, and you put matrix A second. These two numbers don't match, so you cannot multiply those two together. And there will be some questions on the test. It will be just simply that, hey, here's these two matrices. Can you multiply these two together? Yes, you can, or no, you can't. And there'll be some questions in the homework, same way. If the two numbers in the middle are equal and you put them side by side, yes, you can. If these two numbers are not equal, then no, you cannot. And that's it. Okay, so to actually multiply, so this is just figuring out if you can multiply these two things together or not. To actually multiply them, what you're going to have to do is you're going to have to multiply every row of the first matrix by every column of the second matrix. And then we'll kind of figure out and go from there. And I was going to try to put in here more details of what to do for this one. It's one of those things that it's really hard to write down all the steps, what you have to do. It's more of once you see the examples, it's easier to kind of see what exactly it is that we're going to do for this one. So here's what we're going to do. Okay, so let's go ahead and do this. Let's say we're going to multiply, let's say matrix A is 2, 1, negative 3, 7. Matrix B, negative 1, 5, 4, and 6. Okay, and again, what you're going to have to do is you're going to have to multiply every row of A times every column of B. And you can almost do this. I have some people doing this earlier. They were having trouble with it. So I was like, okay, if you write these down on a piece of paper, I would take a sticky note, or if you've got something you got, basically just cover up everything other than the first row. So when we do these, we do row times columns. We're going to do this row times this column. Okay, and what you're going to do is you're going to multiply the first number here times the first number here. So first row times the first column. So first row of A times the first column of B. So they're going to give you matrix A, they're going to give you matrix B, and they're going to tell you to find A times B. Tell me what that's going to be. So again, we're going to do 2 times 1 times this one. So we're going to do 2 times negative 1. And we're going to add that to second number here times second number here, and 1 times 4. So it's negative 2 plus 4. That is negative 2. Okay, and again, not hard multiplication. You're just adding and subtracting after you multiply everything out. It's just making sure you know what you're going to do. Now we're going to do the first row times the second column.
Mr. Richardson,
Yes.
how did you get negative 2?
Oh, so we did 2 times negative 1,
How'd you get
which
your
would be negative
answer
2.
set?
Oh, so it's always going to be the first number in this row times the first number in this column. And then we're going to go to the second number here and the second number here. So we're going to move this way on this one and move this way here. So it's 2 times negative 1 and then 1 times 4.
And then you added them both.
And then you're going to add that number together. Yeah. So after you multiply these two numbers together and then you multiply the second numbers together, you're always going to add or subtract depending on what the signs are for that particular problem. Okay. And then we're going to do the same thing. Now we're going to do this row times this column. So again, basically you can just kind of cover that one up now. So now we're going to do 2 times 5. We're going to add that to 1 times 6. So that's 10 plus 6. That would be 16. Oh, I'm sorry. That's what y'all were saying. All right. I got you now. Okay, totally. Now I see it. Yeah, let's don't make that a negative 2. What are y'all talking about? There's not a negative 2 there. I don't know what y'all talking about. It's positive 2. Sorry about that. Yeah, I totally misunderstood what you were asking me. Okay, so first row, first column, and then after you take that row, then you go to the next column and then go from there. Yeah, sorry about the negative 2 there. Just totally wasn't paying attention. Okay, and then once you've done everything with the first row, there's no more columns to go. Now we're going to go to the second row, and we're going to repeat that same thing. Now we're going to take the second row. Now we're going to take the second row of A, and we're going to multiply it by the first column again. So now we're going to do negative 3 times 7 times negative 1, 4. So we got negative 3 times negative 1. Make sure I get my signs correct this time. And then plus 7 times 4. So that's 3 plus 28. That would be 31. So again, now we're doing that row times that column. Once we've done that one, now we're going to go to the next column. So now it's the first is done. So now we're going to go second row times second column. So now we're doing negative 3 times 5. And we're going to add that to 7 times 6. That's negative, can't see that one. Negative 15 plus 42. That is 27. Okay, and as long as you kind of keep the rows going at the same time, basically there's your 4 numbers we need. So we need 2 and then 16. And then on the bottom, we're going to have 31 and then 27. Okay, so this part of it, I'm going to go to like actual line paper for this part just because just a little bit easier that way. All right, so let's give you one here that looks a little bit different. We're going to practice on also knowing what the size of it's going to be. So let's say that we're going to do X is 10, 1, 0, 9, 6, 1, negative 1, 5. And then Y is going to equal Let's go 6, 3, 5, 1. Okay, now it seems like it's not a big thing, but it's a big thing. You've got to be able to figure out the size of the different matrices that we're going to work with. So we're talking about X. How many rows do we have? Rows are going this way, right? So we got one here, we got one here. So we got it's a 2 by. If you count the columns, that's the part that should be easier. 1, 2, 3, 4. That's a 2 by 4 matrix. Okay, with Y, 1, 2, 3, 4 rows. There's only one column, so it's a 4 by 1 matrix. So again, the question usually they would ask you is, can you multiply X times Y together? All right, we got 4s in the middle, so yes, you can. We know that once we do X times Y, that the answer should be a 2 by 1 matrix when you get there. So again, these two things have to be the same. They are equal, so we're good to go. So then the answer should be a 2 by 1 matrix, which means we'll have 2 rows and only 1 column of answers for this. Okay, so again, when we multiply, it's always the rows times the columns. So we're going to start off by multiplying 10109 times the only column we have here, 6351. So it's going to be 10 times 6, 1 times 3, 0 times 5, and then 9 times 1. So we got 60 plus 3 plus 0 plus 9. Okay, so at 63 plus 9, that should just be 72. Okay, and then once we've done that row, now we're going to do the second row, which is the only one that's left. So now we're going to do this row times this column. So we've got 6 times 6. We've got 1 times 3. We've got negative 1 times 5. And then 5 times 1. Okay, so we got 36 plus 3 minus 5 plus 5. So that's 39. The plus 5 minus 5 cancel, so that's just 39. Okay. Again, for the answer is a 2 by, sorry, I can't see it there. The answer is a 2 by 1 matrix. We need 2 rows, so we need 2 blocks here and only 1 column. So basically, that's our answer there. So it's 72 and then 39. Okay. Again, it's one of those things where it's not hard. It's just you've got to keep up with. Somebody said earlier in the day, it's a process. Yeah, you just got to kind of keep up with the process of what you're doing. That you always got to remember that you're going to take whatever the row is you have here, and you got to multiply it by the numbers that's in the column that's going to be here. It's always these numbers times these numbers, and just add those different pieces together. Sometimes it's always a nice square. Sometimes you're going to get an answer that just maybe only has a couple answers to it. Okay, and then I think the last big thing we've got to look at, and again, multiplication, we can keep giving you more problems, but it just honestly it comes down to just practice on those. So then the last big thing we've got to look at is, then I'll start to work. There we go. Is determinants. And for the word determinant, for short, they just call it DET. And for this one, we're only going to do a 2 by 2 matrix. There's all kinds of other matrices we can do with. We're only going to do a 2 by 2 because to get a 2 by 2 determinant, it's really pretty straightforward, really pretty easy for this thing. Okay, so we're going to show it to you just in a way where it's just a bunch of letters first, just so you can get it. Then we'll actually just give you a couple of problems you can do with it here. Okay, so if matrix A is just A, B, C, D, whatever the numbers are here, it doesn't matter when we're going to do this one. The determinant of A is basically just a number that we're looking for. So all you're going to do is you're going to take whatever this matrix is you have here. And again, here's where it's going to be easy math. This should be like something really easy for you to do. You're going to do cross products. You just have to remember when you do your cross products, you just have to go up. So it's A times D and then minus B times C. Okay, and that's it. We're just, so determinant is just a number. And then we'll show you what we'll do with that number once we've got it. But the main thing is we're just trying to figure out how to find a determinant. We don't have to do a bunch of examples because once you've seen one of these, they're all exactly the same as it goes through this part. Okay, so let's give you one where we're going to actually find out what the determinant's going to be here. Okay, so let's do this. So they'll tell you, find the determinant of A when A is going to equal 2, 5, -4, and then 8, maybe. Let's see. Okay, so for determinant, all we're going to do is just, again, take whatever matrix you've got. We're just going to do cross products. But again, make sure you multiply up. So it's 2 times 8 for 16. And it's always minus. We've got -4 times 5 would be -20. So in that case, it winds up being minus a negative. So it means it's really just 16 plus 20. So the determinant's going to be 36. Okay, and then a couple of little things we've got from this one, and we'll get this here. And I'll run out of room at the bottom here. So again, for determinant, that's all you have to do. Just do cross products. You got that one. And then if whatever determinant you're doing, if you find out what the determinant is, if the determinant equals 0, then that matrix does not have an inverse. Okay, and basically inverses are when we talk about something being an inverse, basically is this, that if you do, and here's where we'll kind of tie in the last little piece of this together, that if you do A times B, whatever the matrix is for A and whatever the matrix is for B, if you multiply those two together, if your answer is equal to something like this, where you got 1, 0, 0, 1, then matrix B is the inverse of A. Okay. And if something is inverse, they show that by doing whatever the matrix is, and they put a -1 in the exponent. Okay, now here's where all that ties in together with everything that we're going to do. So what we're going to do for this part is going to give you two matrices and just going to ask you, okay, are these two matrices, are they inverses of each other? And all you have to do is you're going to take whatever the two matrices are, you multiply them together. If you get this, they're inverses. If you get anything other than this, if this was like -1, 0, or 1, 1, 0, 1, if you get anything other than this matrix, they are not going to be inverses of each other. So it's just taking the multiplication part that we just talked about doing and just stretching this out so it's just a little bit more of one more thing. Okay. So here we go. Here's where we'll tie this in together here. So our matrix A, we'll say it's 1, 1, and then 5, 4. Okay, so they're going to ask you this. So our A is 1, 1, 5, 4. B is -4, 1, 5, -1. They're just going to ask you, are these two thing inverses? So all we have to do is we've got to do A times B. And if that answer comes out to be this, they are. If it's anything other than that, then it's not going to be. Okay, so it's going to be just another multiplication problem. So we're going to do A times B, so it's 1, 1, 5, 4 times -4, 1, and then 5, -1. Okay, so just practicing the multiplication for this thing. And we're just trying to figure out what this part equals. And again, if it's this is the answer, it's yes. If it's anything other than that, then the answer is going to be no. Okay, so multiplication again. We're going to take the first row and multiply it by the first column. So that's 1 times -4, and then 1 times 5. So it's -4 plus 5, which is 1. So far that one's good. Okay. So that first number is good. So the next number over here, we're going to do the same thing again. Now it's this row times the next column. So that's 1 times 1, and then plus 1 times -1. A lot of ones. So that's just 1 minus 1, which does equal 0. So first number is 1, second number is 0. That one's good. So then for the second row, we'll do the same thing now. Now we're going to multiply this row times this column. So we've got 5 times -4 plus 4 times -5. So it's a -20 and a +20. Wait a minute. 5 times 4. Oh, that's not a -5. Sorry, it's just a 5. So -20 plus 20, that is 0. And then one more time, this row times that column. So we got 5 times 1 plus 4 times -1. So first number here, second number here, second number here. That is 5 minus 4, which does equal 1. Okay, and there's your matrix right there. So it's 1, 0, 0, 1. So are the inverses? There you go. Okay. Again, for them to be inverses, it has to be that. Anything else other than that, it's a big fat no. So if this number was -1, that's a no. If this number was 8, that's a no. If this number was a 4, that's a no. So it always has to be 1001 for that thing to work out. Okay.